What do you know about rational functions?
Rational functions.
Rational functions, what do you know?
Have fractions.
Yeah, they have fractions and they're functions. That's all you know. Just by those words. Doesn't rational mean a fraction? And a function is a function of a relationship between, yeah, well, rational functions, they don't have fractions, like the coefficients aren't fractions. It's not like 1/3 x squared. No, that's not a rational. Rational function is like, one example would be like x squared plus 5x plus 7 over x plus 3. So you got like a function over a function. Craziness. We're going to graph them. The one you do know about is probably 1 over x. You've seen a graph of that, right? The first section of this, we're supposed to talk about domain of rational functions, but we've already done domain of these. You should know how to find the domain. What would be the domain of that guy? X cannot equal 0. Why can't x equal 0?
0 can be at the bottom of a fraction.
Because 0 can't be at the bottom of a fraction. Yep, x can't equal 0. You know what the graph looks like?
Isn't it the one with the 2?
The 2, yeah. What's it have right here on the x-axis? Yeah, an asymptote. There's an asymptote there. Is there another one? There's one right here. And then
What is your problem?
this.
What you want?
If you wanted to graph it, you could plug in points, right? You could always plug in points. You could just make yourself a little table. X, y. When x is 1, y is 1. When x is 2 is a half. 3 is a third. Right? You can plug in points on anything. So the way you're going to graph these rational functions, you're going to find where the asymptotes are, and then you're going to plug in points. And that's how you graph a rational function. Kind of, but it's going to get a little more complicated.
I've already done this.
Kind of, but it's just
Kind of. It's going to be a little more complicated.
Oh, it's like, I didn't hear you. It's a break.
So to find where the asymptotes are, let's say we have a function. We definitely have not done anything like that. Graph that. I bet you could tell me where the vertical asymptotes are.
The vertical?
Vertical asymptotes. Where would there be vertical asymptotes?
0.
0? What do you mean 0?
The y.
Oh, the y-axis? That's only on 1 over x. So
That vertical doesn't.
vertical's up and down.
Oh.
So let's find our, because you're going to find vertical asymptotes. You're going
It's
to
2.
find if there's any horizontal asymptotes. Tomorrow you'll learn about slant asymptotes.
Oh, gosh.
Not today. Just vertical and horizontal today. So this one will have vertical and horizontal asymptotes. Probably, maybe. I don't know.
So I have to
Don't know? Okay, let's find the domain. What's the domain of this?
X could not equal.
all real numbers.
You sure?
Yeah.
What?
Oh, because
Because
it's X
you
squared.
have a negative and you put it through, it's
It's the
1.
plus 1 to make it not 0.
Yeah. So this is bad.
Yeah.
Bad first example. I just picked this randomly on the pope. So the domain is all real numbers because, for that to be -1, can it? You'd have to have a negative, or you could just go find domain 3x squared plus 1, set it equal to 0. When will the bottom equal 0? Because that x can't be that, right? Well, if you do that, -1, so So 3x squared equals negative 1 divided by 3. X squared equals negative 1/3. Hey, it never will, unless we do imaginary numbers and we're not. X squared never will equal negative 1/3. So this bottom part will never equal 0. Therefore, the domain is all real numbers. So are there any vertical asymptotes?
No.
No, because if there's a vertical asymptote on a graph, it never touches it. That's not in the domain. Like back to this one. The domain was x cannot equal 0.
So they're gonna pass.
So at x equals 0, there's a vertical asymptote. If we do another one, if I can pick a better example, I'll just make one up instead of trying to pick one. 2x over x plus 1.
So x cannot equal negative 1.
Yeah, for the domain, x cannot equal negative 1. Guess what happens at negative
There's
1?
a vertical asymptote.
There's a vertical asymptote. So at negative 1, we would have a vertical asymptote. And that is how you find vertical asymptotes. That's where the bottom, set the bottom equal to 0 and solve for x. So let's probably put this in like note form. Vertical asymptotes. I could write it like that, or I could just say, to find them, just set the denominator equal to 0. Solve for x. That's it. That's vertical asymptotes. Horizontal is a little more tricky. There's actually a really easy way to do it using calculus, but
Can't do that.
do that. But there is another way to do it without calculus. Now I'm trying to think of a simpler way to write this. The book writes it as f of x. If this is your function, p of x over q of x. All right, it's a function over a function. It's like on this one. It's just saying, here's our numerator and our denominator. The top one, they write it a sub n of x to the n plus a sub
What is
n
this
minus-
one?
That's why I didn't want to do it.
Don't.
Let's just say on the top you're going to have a function, right? A polynomial. A bunch of x's and y, or not y's, a bunch of, you're going to have something x to a power plus something x to a slightly smaller power plus something x to a smaller.
This is the 0. Throwing in words is going.
Like if n was 5, this would be x to the 5th plus something x to the 4th plus something x to the 3rd. That's all that means. Over, the bottom will also have it. Right? You're going to have something over, you're going to have, in this case, n would be 1 and m would also be 1. It's just, that's just the power of the leading term. Or the order of that, right? The order of the, what was the other word? The highest power. You're looking at the highest power on the top and on the bottom. It's like on this one, the highest power was 1. On that one, the highest power was 2, right?
Yeah.
On this one, they're both 1. All right, here's what you do. If n's on top and n's on bottom, like this. If n is less than m, so if the power on top is smaller than the power on bottom, the x-axis is the horizontal asymptote.
If the top is smaller than the power on the bottom.
If the power on top is smaller than the power on bottom, the x-axis is your horizontal asymptote.
So 0.
X to the third over X squared.
That's bigger on top. This is,
Squared. over
the
X
top is
squared.
smaller than the bottom. So like this one, the x-axis would have been a horizontal asymptote if we were to graph it. 1 over x. There is 1 over x, the power on top is 0, power on bottom is 1. That's why the x-axis is a horizontal asymptote.
Math has the weirdest rules.
If they're the same, like this one. Power on top's 1, power on bottom's 1. Then it gets tricky. You got to do the coefficient of the top one divided by the coefficient of the bottom one. That's why they write it like this, so that you can define it. So if this is a x to the n, and this is b x to the m on bottom, then y equals a divided by b is your horizontal asymptote.
So it's 1 on top, 2 on top, and 1 on the bottom, the asymptote is
Y equals 2. So at y equals 2, that's,
So you divide the coefficient.
yeah, the leading coefficients, you just divide them. So like for this one, your horizontal asymptote, leading coefficient is 2 and 1, so it's y equals 2 over 1, so it's just y equals 2. So at 2, you'd have a horizontal asymptote.
Y equals A over B. This is so confusing.
What?
Can we just wait till next year to do this?
No, I'm not here. How about at least
You're gonna have to review all
Tomorrow
of this.
slants.
if n is greater than
If n is greater than m, so if the power on top is bigger than the power on bottom, this one's really easy. There is
There is
no
no.
horizontal asymptote. You just go too hard and just flip your hand.
And that's enough for today?
Well, no, now we're going to do a few cases and find the horizontal asymptotes.
Can we try them?
Plenty of time, we got 8 minutes. It's
You have 4.
1/6 of the class. Okay, so let's find some horizontal asymptotes.
More than that?
Yeah. I'll just do these one more time. Tell me the horizontal asymptote of this. What's the horizontal asymptote of this?
Wait, we're looking at the x things, right? Powers? So what's it saying?
Look what you did.
I know that. Oh, equals the. Then, yeah. So you have what, 2 over 3? Oh, this is
That way everything in a vertical order and a horizontal order.
Horizontal. Just do the horizontals. These have no verticals. Verticals are easy. I'm just writing random stuff up here. There you go. Find all the horizontal asymptotes. This is very sloppy.
You're gonna draw a graph or just
No. Horizontal asymptotes right now. Easy deal.
So you put the number in front of the x?
Okay. First one.
2/3.
Yeah, that's what I was asking.
powers are the same, right?
So they equal, you put something over the other.
So if n equals m, y equals a over b. So it'll be y equals coefficients 2/3.
That's all I was asking, if it's a coefficient.
It's 2/3.
The second one, there is none.
I don't know. X to the third over x squared.
There's none.
N is greater than no horizontal asymptote.
Same with the next.
X to the third over x squared. There isn't one. What about this one?
Divide 6 by 2 because they're the same.
It's y equals 3. Easy, isn't it? Okay. Verticals. Could we do verticals? Give you one more. Find the horizontal and verticals. And the horizontal and vertical asymptotes.
Wait, how do you know if there's no vertical again? Can you go over that?
Set the bottom equal to 0 and solve for x. If you have a solution, there's no vertical asymptote.
No solution. Yeah, we think the quadratic equation. X squared minus 3x plus 6 equal to 0.
I know, on both horizontal and verticals. Might as well ask for the domain too while we're at it.
Wait, so if it's, you're not the factor, right?
Yeah.
Okay, and if it's not backwards, you do part of it.
It's factorial.
Not that one.
Yeah, it is.
No, I'm not talking about that problem.
Oh, yeah, if it's not factorable, yeah, you do quadratic. They will be in this.
Wait, so we're only doing that one?
Yeah, just this one.
Okay.
Well, unless you want to start this way.
No. I was doing the other problem we did.
Once you get your x's,
This is 2 over 3, this is 3 power, this is power 8.
Speak. Jeanette, speak.
thinking how to speak.
So after you factor them, instead of both equal to
But 2 and 1, so you do 1, 2, and 1.
That's it. Vertical asymptotes, it's where the bottom equals 0, right? So x squared minus 3x plus 2 equals 0. That's x minus 2. That's x minus 1. So x equals 2 and x equals 1.
That's
the
vertical,
horizontal
right?
one is
Those
the
are,
x.
you have 2 vertical asymptotes. So if you were going to graph this, at 1, there would be a vertical, and at 2, there would be a vertical.
And the other one is the
There's no
x-axis.
horizontal.
Horizontal, bottom power is bigger than the top.
It's the x-axis.
No.
Wait, bottom's bigger than the top?
Bottom is bigger than the top, or top is smaller than the bottom. I guess I should say it that way.
I'm like, what?
The top is smaller than the bottom.
10 is greater
So
than
the
x than
x-axis
10.
is the horizontal.
So the horizontal is the
Yeah,
x-axis.
listen, I was stupid. I know.
Oh, wait.
I just said
What?
that.
So you're part of the way to graphing. Now it's we'll finish her up another day. For
Is
now,
that all real numbers?
what?
All real
Oh,
numbers?
domain. No, it's not all real numbers.
It's x squared.
On the bottom, but your vertical asymptotes in your domain. Guess what? It's gonna be almost
X cannot equal negative
x cannot equal 2.
2 and x cannot
X
equal 1.
cannot equal 1. That's it. Look at 1 through 12. 1 through 6 is exactly this.
That's, yeah.
7 through 12 is looking at graphs.